Guys, Mr. Klein here with our tutorial on completing the lab report for your powered car project rather. What we're going to be doing is we're going to be going step by step through this project. I have a worksheet which I've done already. And I'm going to actually be working my way through this. So this is actually going to be a very long video, but the upside to it is going to be that you're going to see me going through this step by step. So whenever you're working on a particular part, just like when you watch my videos, you can pause it and then do your problems and make sure you did it right based on what I did and go on. So let's go ahead and get started. So what we did was, of course, in class on Friday, you raced your cars 3 times. You got all your information. Now on Thursday in class, you brought your car. You measured the length, the width, the mass, and then drew. Okay, so this is a hypothetical car I created. Then, hypothetically, in class on Friday, I raced my car and I got this information. Now, of course, you know in class that this is the time, the distance. Oop, let me let it zoom in. Okay, so we have the time, the distance, and then also the path it took. This is like the scientific data that a scientist would want to know. So we know and we have all that. Rather, we want to go through all of this stuff about race analysis. So let's go ahead and let's do that and let's dive into that. The first thing you're going to do is speed and acceleration. Okay, remember, speed is the distance traveled over rate at which distance travels over time. Acceleration is how much your car sped up or slowed down, any change in speed or direction over time. So what we're going to do is we're going to use these formulas. Speed equals distance divided by time, or S equals D divided by T. And acceleration, of course, is V2 minus V1 divided by T. What we're going to do is we're going to use the data from each race. And we're going to go ahead and we're going to calculate it. So I took my information, and here's for my races. What I'm going to do is I'm just going to do the first example of speed and acceleration, and then you guys can do all three for each race. So for race 1, my car traveled 652 centimeters in 12.48 seconds. So what I'm going to do is I'm going to write the distance. The distance, of course, was 652 centimeters. So let me write that down, 652 centimeters. Now, the proper metric unit for speed is in meters per second, but if you notice, our information is in centimeters. So we need to convert centimeters to meters. And of course, what we do is we divide that rather by 100. 652 divided by 100 is 6.52 meters. Okay, we're going to round to 1 decimal place, and we're just going to round it up to we're going to round it at 6.5. Okay, so our distance is 6.5 meters. So I have that, and I'm going to go right here, and I'm going to write this in, 6.5 meters. Okay, now we have our time. My time for my first race was 12.48 seconds. So I'm going to write this right here, 12.48. Okay, so 6.5 divided by 12.48. So what I'm going to do is I'm going to have my calculator and put 6.5 divided by 12.48. That's distance divided by time. Gives me an answer of, oh, goodness gracious, big numbers. 0.52083333333. Okay, we're only going to round just to 1 decimal place. So it's 0.5. Now, is it 0.5 or do we round it up to 0.6? Well, we look at the 2 right here, and we see that it's less than 5. So 5 stays. So what I'm going to do is I'm going to put my time in at 0.5 meters per second. And by the way, right here, just for purposes, see where I have time? You should figure it out by now. 12.48 was my time. So what I'm making you do is I'm actually making you put the information and then plug it in. So what we're now going to do is we're going to do acceleration. Okay? Our average acceleration, remember, V2 minus V1 divided by T. Now we're averaging out all of the acceleration from the car speeding up and slowing down to a stop. Okay, it's not perfect, but you can see how it works. So this is a 2-step problem. Okay, we have our speed of 0.5. Okay, that's our final speed. That's the average speed of it. We're going to put in 0.5. Okay, 0.5 minus 0, of course, is 0.5 divided by this time, 12.48. Okay, right here. Our number is going to be really small, so we might break our rule of 1 decimal place. So what I'm going to do Let's put 0.5 divided by 12.48. Gives me an answer of a really small number, 0.04. So what you can actually do is you can actually put, go to 3 decimal places, 0.40. Okay, and if you remember, I told you this in class. You put 0.040 meters per second squared. Now, once you have that done, what you want to do is you want to take these two boxed answers and look down here at the bottom of the page. So we have our speed. My speed for race 1 was 0.5 meters per second. Okay, my average acceleration was 0.040 meters per second squared. If you notice right here, I've actually given you the units. So you want to go ahead and put these at the end of each. Now that you've seen how I've done my first race, which I want you to go ahead and do is take your information from your race results for race 2, right here, okay? And let me let it zoom in, okay? Our race 2 results, and do the exact same thing for race 2. Put your answers in the box, and then put them right here, and then the same thing for race 3 right here, okay? So that's how you determine the speed and acceleration. So you're probably going to pause right here and get all the information and go back. All right, so obviously you did that, and you got your speed and acceleration. You wrote it all in here in this box. You're going to need your speed and acceleration later. So let's go to the next part. Okay, the next part is Newton's law of motion. Remember that an object's motion will not change unless an unbalanced force acts upon it. There you go. Come on, zoom in. Okay, so in the box, draw Newton's first law of motion in action like how you described. So what you want to do is you want to write something you observed about an object's in motion staying in motion, or an object at rest staying at rest unless an unbalanced force acts upon it. You write a description and then you draw it. And you want to make sure you label the unbalanced force or balanced force and it's staying in place. And then you also need to answer these two questions. During your races, where could you observe rolling friction? And what kind of friction do you observe as your car drew through the air in the hallway? You want to go back and look at your notes on friction, on Newton's first law, and use that information in order to answer that. Okay, so now we're on to Newton's second law. Okay, remember Newton's second law, we determined force. Force equals mass times acceleration, or F equals ma. Okay, so we need our mass and our acceleration. Now, we put our mass in our very first thing in our lab information where we figured it out in grams. Okay, right here. Now, your grams, your mass of your car was nowhere near as much as mine. I'm using the example I showed in class, 56.2 grams. So what I'm going to do is I'm going to write right here the mass was 56.2, and that's from the first page. And just like because it's in grams and we have to turn it to kilograms, we need to not do it by 100. Ugh, big mistake right here. Scratch this out, right? 1,000. I need to fire that person that did this worksheet, and we need to divide this. So what I'm going to do is I'm going to take my calculator. Okay, we'll put it where you can see. We'll clear it out. Okay, and so my total was 56.2. I'm going to divide it by 1,000. Okay, because 1,000 grams makes a kilogram. And I get this answer, 0.562. Okay, you can go to 4 decimal places, which is, we'll go to 3 decimal places. So 0.05. Does it stay at 6 or go to 7? Well, it's at 2. 2 is less than 5, so we keep it the same. 0.056 kilograms. Okay, so that was the mass of our car. Okay, we're going to use this number right here for all 3 problems. Okay, so make sure we do that. Now, from the acceleration, from the summary form, okay, you pull up this information, remember? Okay, you see acceleration where I have 0.040. I'm going to write that in. 0.040 meters per second squared. Make sure you're using it for race 1. You don't want to get your races mixed up. Okay, that's why we're doing them in order for each. So what we need to do is we need to multiply. Force equals mass in kilograms, 0.040 0.056 times 0.040. Okay, so what I'm going to do is I'm going to do the math right now. 0.056 times 0.040. Okay, that's my two things. I get an answer of, whoa, really, really small. 0.00224. Okay, go to 3 decimal places. 0.002. Does it go up to 3? No, this is less than 5. So we'll go to 0.002 newtons. Okay, spoiler alert. Okay, we'll change this to 3 because it was so small. Your values will be really, really tiny, okay? Because you have not a lot of mass and it's not going very fast. Remember, a newton is the force needed to move 1 kilogram at 1 meter per second squared acceleration. That's way more than what your car was actually doing, even though it seemed pretty quickly. So now that I have this force, 0.002 newtons, and these 3 answers will probably be similar. What I'm going to do is right here on this page, I'm going to put my answer, 0.002 newtons. This is the unit I'm going to put right here. And what you're going to do now is you're going to do the next for races 2 and 3. So go ahead and pause it, do races 2 and 3, and come back to me. All right, so you figured out your force. You saw they were really, really small, and that's Newton's second law. The force of your balloon-powered car was the equivalent to its mass times its acceleration. And our acceleration for this wasn't exact for a moment in time. Rather, it was averaged out from it speeding up and slowing down. But we're doing the math just so you can know that. So we have Newton's third law. For every action, there's an equal and opposite reaction. I want you to draw the top view of your car, but just turn it sideways. And draw and label the arrows representing the action and reaction of your car in motion. So you're going to go ahead and you're going to draw that right here. No, I'm not drawing it to give away the answer. You should know that. Okay, remember, if you don't quite know it, go over it in your notes. So the next part is to calculate the momentum. Okay, remember, momentum is a measurement of the velocity and mass of an object in motion. Okay, then we use the formula momentum equals mass times velocity, or P equals m times v. Okay, so we know our mass, remember, from our car section. Let me get my paper, my big old pile. Okay, so my mass was 56.2 grams. Yours is much smaller. Okay, so 56.2, just like last time. We're not dividing by 100, it's dividing by 1,000. Okay, and that, of course, gives me 0.056. Okay, some of you clever people might copy this. I would much rather you do the math every time just for practice, okay? Your speed value, okay? Use your speed value from the same place where you found the acceleration for force, right here. Okay, my race value was 0.5 meters per second for the first race. So I'm going to put 0.5 meters per second. Okay, so I'm going to plug in my information. My mass, kg, 0.056. My velocity, 0.5. Okay, so we're going to multiply 0.056 times 0.5, giving me an answer of 0.028. Okay, once again, we're going to round to 3 decimal places just because our answers are really small. So we're going to write 0.028. Okay, 3 decimal places. Once again, the momentum is not a lot because your car doesn't have a lot of mass, and also in the grand scheme of things, it wasn't going very fast. What I'm going to do now is I'm going to take my answer and I'm going to put it in this table about momentum. Let it zoom in. There we go. Okay, so my momentum was 0.028 kilogram meters per second. We want to make sure we use these units. Okay, so what I want you to do is I want you to pause the video right now. Once you're done, you come back to me. We're going to go over work and power for this. All right, so you've done your other 2 momentum races, and we're actually almost done. Look, we're on pages 6 of 7. Okay, so we're almost done. We're doing work and we're doing power. Okay, let's zoom in. So work is equivalent to your force times your distance, or work equals F times D. Now, so there was a force that applied to your car, and it went a certain distance. Therefore, work was actually done. So let's go back to race 1. We have this information. Okay, From the summary form above on force, we need to write what our force was. Remember, my force was right here, 0.002 newtons. So I'm going to write this 0.002 newtons. Now, I need to put my distance of my first race, which we're going, remember that? I'm going to put that right here, 652 centimeters. Okay, 652 centimeters, we need to convert this to meters. Okay, so 652 divided by 100 gives me 6.52. Okay, and if you notice by now, these numbers keep on coming up. Every time you use distance, you convert it to meters. It's the same thing. Okay, so let's go ahead and let's put in our information. Okay, not in centimeters, but rather 6.52 meters times, because work equals force times distance, the force, 0.002. So what I'm going to do, I'm going to take this, I'm going to multiply it by 0.002. Gives me an answer of 0.0130. So let's round this to 3 decimal places, and that tells us joules. Joules is a form of energy. Okay, so let's round this up to 3 decimal places, and we'll go to 0.013. Okay, because the 0 means we don't need to round it up. Once again, we're going to take this answer in the box. Sorry about that. Okay, take this, okay, 0.013, and we're going to put this answer on the last page in our box where it has work in joules. So we got 0.013 joules with the letter J. Okay, so we have this for the first one. Remember, what you do is you take the force, okay, your force from Newton's second law, and you multiply by the distance from the race. Okay, so you take, for races 2 and 3, the force you determine, and you multiply by the distance from that race, and then you multiply and you get your answer and put these boxed answers in the organizer. So go ahead and do that. Pause the video, and whenever we come back, we'll do our last section on power. All right, so finally we're working on power. Okay, so remember, power is the amount of work done in a given amount of time. Okay, so what you have is we need to calculate the power for each race. We use the formula work divided by time, or P equals W divided by T. Okay, so we have our answer in joules right here. So we're going to put it from race 1, 0.013. Okay, we need the time for our first race in seconds. So let me go ahead and let me pull up my information from race number 1. And I saw my car went in 12.48 seconds. 12.48 seconds. Now, and you're probably already figuring this out, that number is going to be super small. Okay, so we'll go to several decimal places. So let me take out my calculator, 0.013, and I'm going to divide by 12.48. That gives me a super small number. Let's go ahead and let's go, instead of to 3 decimal places, let's go to 5. That way we can see how precise it is. So we're going to go to 0.00104. Okay? And because it's at 0.41, okay, this 1 doesn't round it up. Okay, so we went to 5 decimal places. So we want to make sure, write your answer out to 5 decimal places. And finally, if you see down here, okay, we want to write our answers in watts right here. So we have 0.00104. Okay, and we're going to put our letter in watts because that's our unit of power. So, you know, if you think about it, your light bulb in your room might be 60 watts. Well, this is like several thousand, the amount of power used to power your car was several thousand times smaller the amount of power needed to light your light bulb. So, there we go. We've gone through a whole lot of stuff. You can go ahead and pause right now, or rather just let me finish this video and you can go and finish this. Just some notes to know is that I'm really going to be checking right here in these boxes for your answers. So all you have to do is transfer that, and I'm going to make sure, I'm going to look right here, see what your work is, and then look at the answer and make sure it works out. And I will be checking your work to make sure you've done it correctly, with numbers-wise. I'm going to be checking with the calculator. It's not going to take me very long to do each of your tests to do that. So please make sure you get all this information. So we've gone ahead and we've gone through this. You've taken your data, okay? So we've determined from this race data right here, we've been able to determine speed and acceleration right here. We've been able to determine how we saw Newton's law of motion and friction. We've used Newton's second law, there we go, in order to determine force. We have also determined the momentum of our car. Okay, we've been able to determine our momentum. Okay, and we've also looked at Newton's third law in action. And using all the information we've created thus far, we've determined the amount of work done by our car for each race, and also the amount of power needed to run our car for each race. So there you go. That's the video. Hope this should help you out. Just go through this really, really slow. Go ahead and rewind back to parts that you weren't quite sure and go through it step by step in order to get your answers. So there you go. That's everything for the video. And if, as always, you have any questions, please let me know. And thanks for watching.